my name is Carol. Welcome to the Good Code channel. It is the third week in a row when we are tackling the problem related to binary trees, and it will be the last week. 2 weeks ago, we were tackling the problem that required a solution based on breadth first search. A week ago, we tackled the problem where the way of searching the tree doesn't really matter as long as it was one of two most popular. And today we will tackle a problem where we need to use depth first search. Okay, so we will go to the very last leaf and then track our way back up and so on and so on. And the problem that we will be tackling today is definitely the hardest one. It was asked recently by the Twitter, and the problem is called filter binary trees. And why is this problem so hard? Okay, basically, this is the input to our problem. So we have binary tree that has only ones and twos, just to make it a little bit simpler. And what we want to do is we want to filter out the final leaves with certain value. Okay, so this is the function that we will try to implement. The function takes first node of a tree, root of a tree, as the first argument and the value as a last argument, and the goal is to remove all the final leaves that have value of 1, the value that was passed over here. So what we want to do is remove final leaves with the value of 1. So we remove this element, we remove this element, we remove this element, and due to the fact that those two elements have been removed, we also need to remove this one. So the output will be the binary tree that has root of 1, middle element of 1, and the final leaf of 2. Okay, so we'll try to implement it, and as I said, by far it is the hardest problem that we will tackle. Okay, now that we know what needs to be implemented, let's get down to coding. As always, I very strongly encourage you to try to solve it all by your own, and only after that compare our solutions. It is the best exercise. Okay, so please do it. During the interview I said that this time we are going to use depth first search. So we will travel to the last node, and from this node we will proceed up. Why is that? Basically, because the higher nodes depend on the lower ones. Okay, we don't know if, for example, this node needs to be filtered out or not, if we don't know if it is the last node. Okay, to know if this is the last node, we need to know if this node needs to be filtered out. Yeah, so we need to start from the very bottom and then in the recursive manner try to climb our way back. Okay, so yeah, as for these two blocks of code, how the tree is being organized and how I'm creating it, it was detailedly described 2 weeks ago. The link to that video will be at the very top of the links to this video. So if you need the introduction regarding the subject, feel free to simply visit. I won't be repeating myself here again. Okay, so I will close it, okay, at least that one. And the part that interests us is this function. Okay, this function filters out the binary tree in the way that we described during the intro. And probably most of you will say, why is it so short? Well, it is so short because we managed to fully understand the process and narrow it down to very simple operation. Basically, this is the only operation that actually is happening. The rest of the code, so these two lines and this line, is only passing the node forward and calling the recursive function to get to the very bottom. So yeah, this is basically the only part of the coding that does something. So not a lot of work, but a lot of thinking. So yeah, it balances out. Cool. So let's start debugging. I will hit F5 and choose Node.js as my environment. And this is the code that we said needs to work. Okay, So we call the filter out function, we pass root of the tree and the element value that we want to be filtered out. Cool. So let's hit F10 and see how the function is being organized. The function is being organized the way we should be thinking about this kind of problems. Okay, so we go down as far as possible. So the first two lines of the functions that whether it's graph or tree, well, basically graph and tree are the same. It only depends if they have cycles or not. Whether it's graph or tree, if we need to go deep, we always start the functions by calling another instance of the recurrent function with the child elements. And this is exactly what we are doing here. So I'm checking if the left node exists, so that's one. I want the left node to become of the result of filtering this left node, okay? So I'm calling this function for this node when I'm here, okay? So, okay, F10, okay, and we are over here again. And now our node is this one. And it has one child, and the second child, the right node, is null, so we are free to skip it. Okay, so again, we need to go as deep as possible. So for the left node, we call the function filter out with the left node as a parameter and the value as a parameter, and we will assign it to the node that we are calling it for. Okay, cool. And we are in this node right now. So again, we need to go deeper because we don't know if we need to filter this node out or not. If it isn't the last node. Okay, so we go deeper and we are at the very place we needed to be. So in here, at the very bottom of our all left kids root, and this node is null, this node is null, so line 3.3 and line 3.4 will be skipped. And now we get to the very interesting part. Let's think what we will do with the nodes if we were to solve this problem on the sheet of paper. We will take a look if this is the last node and if this node value matches the value we passed over here. So if node doesn't have a right child, if node doesn't have a left child, and the value, the ID of the node matches the value we passed as the filter out argument, then this node is to disappear. And by disappearing, when we are using the objective programming, we can say we want it to be null. And this is exactly what we are doing. We are changing node into null. So, okay, node has been changed. And now we are returning this node. And this is the very clue of the program. We are returning it. So F10 again, and look, now we are back and in our node ID 2, so this one, but now the node left that was one of the arguments for the filter out function was removed, okay, because it matched the filter out parameters. So now this node with the ID of 2 is the last child, okay, the last leaf of the tree. So we're not calling anything for the right node, and now we know that this node won't be filtered out, not because it's not the last node, because it is, but because it doesn't match the condition ID equals value, okay, so we are free to skip it. Okay, node was returned. We are over here. It's not the last node because it has the child, because that child wasn't filtered out. Okay, so yeah, we are back in our main node, in our root, and now we will go down the right path. Okay, we go down once. I know that you still see only once, but now we are here, not here. Okay, we are over here, so we'll call the function for the left node and for the right node. Okay, we are calling it for the left node. We see that it doesn't have any kids, and the condition is okay. So this node is being removed. So replace with a null value. Okay, cool. We are higher, now we are here, and now the left node, this node, has been filtered out. Let's see how the right one is going to act. It's going to act exactly the same, yeah? Because it doesn't have any kids and the condition is true. Okay, so it gets removed. Okay, cool. We are over here again, but now these two kids have been removed. So this is the last child and it also is okay to be removed. Yay, okay. So now we are over here, okay? But this isn't the last node, okay? Because the 2 was over here, so this node wasn't removed. So this node isn't removed, isn't last child because it's a root. Yeah, so it won't get removed. So now that when we take a look on our tree, we will see what is left. What is left is root with the ID of 1, so cool. Right node is null, cool. Left node is 1, so over here. And again, left node is 2, over here. And this left node with ID of 2 was the last child because it doesn't have left node nor the right node. Okay, so the tree was filtered out. Okay, before I'm done, few things I want to point out. Exactly one thing. This function looks deceivingly simple. It is simple because the operations, when we design them correctly, are simple. Okay, the most of the work was done on the paper when I was figuring out how to do it. Okay, remember, first know what you want to code and only after that start coding. Okay, thank you very much. If you enjoyed this video, please like and comment. Bye.